Computer parts. In this video we're going to run through real quickly and show you what's inside a computer. By the end of this video you should be able to explain to someone how a computer works, speak intelligently to a tech support or salesperson, better troubleshoot your own computer problems, recognize a lot of the technical jargon that gets used about computers, and live without fear of what's inside that box on your desk. So to get started, the key to understanding and explaining computers is to be able to put it into terms that you can already wrap your brain around. For example, you could say that computers are like cars. So if you're driving down the road and all of a sudden your car starts going crazy, bumping up and down, you probably know that you're going to have a problem with your tires or suspension or one of the systems that maintains the stability of the machine. Of the car. Say for example you drive down the road and all of a sudden your windshield wipers start flapping around and the radio comes on and off and the lights go. You're going to guess that you have a problem with your electrical system because those parts are controlled by the electrical system. So basically, if you have a basic understanding of how a car is put together, then when you have certain problems, you can figure out how to fix those problems based on that understanding. Same thing with computers. Computers are mechanical systems. If you understand what the basic pieces are, when you start having problems, you'll be able to figure out where those problems are coming from and better able to solve them on your own. The key thing is just not to be scared of your computer. Don't be afraid to open it up, get inside, or see what's going on in there, because you're going to be living with computers for the rest of your life. You'll be better off knowing how to troubleshoot them yourself. Okay, so let me give you the big picture. The computer is built of three main types of components. You have input devices, things like keyboards, mice, cameras, microphones. You have the innards of your computer. That's things like the short-term memory, long-term memory, processor, networking interface, and things like that. Then you have output devices, monitor, speakers, printer. This video is primarily going to focus on the internals because I figure you know what these the input and output devices do. So briefly, these are the things inside your case. There's the motherboard, the processor, a cooler, thermal compound grease, memory, hard drive, an IDE cable or SCSI cable, CD, DVD drives, power supply, network interface card, video card, audio card, modem, potentially, and fans and cables. So I'm going to just go through real quickly and explain what each one of these things is. Okay, starting with the case. The functions of the case are to house and protect all internal components, provide buttons, LEDs, and other sorts of external ways to interact with your computer. They're able to help airflow and cooling. The parts inside your computer get hot, and so the case is designed to help them stay cool. To reduce the noise of fans and things like that are otherwise annoying in your workspace. They can prevent people from stealing the stuff inside. So for example, the computer cases in the computer labs have locks on them. And they also can be designed to look cool. Here's a couple of images of some cases that have been designed by people who get into that sort of thing. Alright, so some words associated with the case is the form factor. Form factor is otherwise known as the size and shape, and some of the words you might hear are ATX, micro ATX, rack mount, mid or full tower machines. These are the types of cases. Alright, the motherboard. Everything is connected to the motherboard. It provides communication between the components, and it monitors the temperatures of the CPU and the other components in there. Some of the jargon associated with it, the socket type. This is the type, in the motherboard is where the CPU gets plugged in. And different CPUs require different socket types. So when you buy a motherboard and a CPU, you need to make sure that the CPU matches up to the socket type. The CPU type, Intel, AMD, those are the two big companies. But even within those companies, they have different processors, different CPUs that go into different types of sockets. A bus is a subsystem that transfers data between components. This is basically a wire, right, that goes between your processor and your hard drive, or between your processor and your RAM, or between your processor and your DVD player, or a bus connects all these components together, and so if the bus speed is slow, it's going to provide a bottleneck, and it's going to slow your whole system down. The chipset is the interface between the CPU and the front side bus. Right, front side bus is one of the buses in the system between the main memory or the RAM and other peripheral buses. Chipset is just important to knowing how fast your system is going to be. Slots are places to provide extensibility to your system, so you can plug in audio cards, video cards, networking cards, and things like that. And then finally we have the BIOS or firmware. This is software that's built into the motherboard itself. It's there to basically turn on the computer every time you hit the power switch. And sometimes we use the word onboard to refer to when video cards and audio cards are built into the actual motherboard. Here's a picture of a motherboard. You can pause the video now if you want to take a closer look at it. Okay, here is the microprocessor or CPU. It manages and carries out all the data manipulations and executes all the programs that get run on the computer. The speed is measured in megahertz or gigahertz and refers to the number of instructions that can be processed per second. You can have single, dual, multi-core. The newer processors these days are multi-core, quad-core, 8-core. They're even getting up to like 32-core, super high numbers of cores on these small chips. They have 32-bit or 64-bit architecture these days. This basically, 64-bit is newer. We're in a transition phase to get to that, and 64-bit computers don't all run the same software, but they can run faster. They can use more memory, things like that. The clock rate can be manipulated for overclocking. This is the clock rate of a CPU is how fast it does its manipulations. And people who get into this can make their 3 gigahertz CPU actually run at 4 gigahertz and stuff like that. But again, you pay a price because it gets hotter, and so you need to think about cooling, and we'll talk about that in a second. A multi-CPU or parallel processing system is one that's is a motherboard that's got multiple sockets, so you can have multiple processors. Things like web servers that have a high load tend to use multiple processing. Some of the brands of CPUs are Intel, which has the Pentium line of Pentium chips, Celeron, things like that, and then AMD, which has got Athlon, Duron, Sempron, things like that. Okay, to go along with your processor, you're definitely going to need a heatsink or a cooler. This keeps your CPU from overheating, and you need to make sure that you get one that fits the socket type, which is on your motherboard. The middle picture there is for water cooling, where it actually uses water instead of air to circulate heat in and out of your system. And that water gets cooled by a little compressor as it comes out. You're also going to need thermal grease, and this facilitates heat conduction from your CPU to your cooler. It's actually like a thin film paste that you wipe on your processor, and then you stick your cooler on top of that to form a nice clean connection between them. Alright, memory. This is the short-term memory. This is a place where data is held while it's being used. If you've ever had your computer crash in the middle of doing something, all the data in the RAM gets lost because it goes away when the power goes off on the computer, and that's why you lose your stuff. So there's SDRAM, and then there's DDR, DD2, DDR3, which each one is 2 times faster than its predecessor. These are just different types of RAM. And then there's PC100, 133, 27. This is the clock speed. Again, just like the CPU, the RAM has a clock speed that can be overclocked and stuff like that. And you just need to make sure that the data rate, the speed of your RAM, matches up with your motherboard and your processor, so that they all work very well together. Hard drive, you know what this is. It provides long-term storage. There are different types, IDE, SCSI, and SATA. This just basically refers to different types of cables that get used to connect it to the hard drive, to the motherboard. There are flash drives. Flash drives have no moving parts, which makes them good for portable devices such as MP3 players and cell phones. Some of the newer computers have what they call a solid state or flash drive, which is a lot more expensive, but it's a lot faster and a lot more durable. In the future, we might see a lot more of those with higher capacities of gigabytes, gigabytes being the unit of data storage for hard drives. Okay, CD DVD drive provides long-term storage. They have plus R, minus R. These are the different types of disks that can work in the CD DVD drives, and they provide different functionality. You want to look at the speeds of your CD DVD drive. Obviously, faster is better. LightScribe is a technology that if you flip the disk over inside of your drive, you can write stuff on it. Kind of cool. Okay, power supply provides and regulates the flow of electricity to all internal and some external components. You basically need to make sure that you have enough wattage of your power supply to cover all of the things that plug into your computer. I had a power supply blow up on me one time. It took the audio card, it took a DVD drive with it. Pretty expensive, so you need to make sure you get a good power supply with your system. Okay, we have a network interface card, and this handles data transfer between the computer and any attached networks. You have Ethernet cards and wireless cards, are the main two types. Ethernet card, technically a wireless card is an Ethernet card, but when we say an Ethernet card, we're usually referring to the wired type, where you're actually plugging in an Ethernet cable or a NIC cable into that system. Frequently, these are built into the motherboard. Finally, we have video and audio cards. These provide interfaces with video and audio input and output devices, microphones, speakers, monitors, TVs, things like that. Video equipment. Main differences between them these days is whether or not they're digital or analog. Newer ones are digital that provide higher quality, cleaner video and audio. Cheaper motherboards frequently have these components already built in, and higher-end graphics cards have what's known as a GPU, a graphics processing unit, which is basically a processor that's built right into the video card. And if you're a gamer, you would definitely want to have this so that you could have the best experience with your games. Okay, so putting it all together, just want to reinforce that computers are not mystical or magical. They're kind of like cars. If you understand how they're put together, when things go wrong, you'll be able to troubleshoot that. You'll be able to talk intelligently to a tech support person on the phone, or otherwise get help. You'll know what terms to type into Google to figure out what's going wrong with your computer. We're going to assemble a PC in class so you like to see and feel what the parts are like and see how they go together. And there are some final ingredients which we didn't cover here, things that you can't touch, things like the operating system, which is software, device drivers, which tell the operating system how to work all of the pieces that are plugged into it, and then application software, which is what you use. Alright, so now you know, and I hope this has been helpful. Alright.